Hello, welcome to the next part. In this one, we'll be going over the electronics, the connections from what to what. We'll be looking at the Pi, loading the software onto it, and running through the different configuration files and whatnot. I've moved inside to my indoor workshop. I've got a really bright light overhead. I'm super washed out, look like a ghost. Oh well, whatever, huh? So without further ado, let's get into it. Alrighty, here we are on the computer. We are just at raspberrypi.com/software. If you go to the Raspberry Pi homepage, you can push the software button up here in order to get to the software page. This is the first piece of software that we will need, the Raspberry Pi Imager. It will allow us to install the Raspberry Pi operating system onto a micro SD card, which is what we need to do. All right, so you can download it for Windows, Mac, or Linux. This computer is on Windows, so I will choose that option. It'll install it up here. Now that it's done, I'll open it. The computer will ask us if we really want to do that. We'll say yes. I'm speaking English, so I'm going to hit OK. And then we will go to the next step. We will accept the agreement. Hopefully I didn't just sign away my soul. I do not want to create a desktop shortcut. Next. It will extract the files. I will see you in a second. And now it is done. So we will launch the Raspberry Pi Imager by hitting Finish. And here we are. So the first order of business here is we need to select our Raspberry Pi device. This is a Raspberry Pi 3B Plus, so I will select Raspberry Pi 3. You need to select whichever one you have, and we'll hit Next. Now, we have a few different options for our operating system, okay? This first one here is the 64-bit Debian Trixie. Then we have the 32-bit Debian Trixie, as well as the legacy 32-bit, which is the Debian Bookworm. I am going to select the Bookworm. Now, I tried originally, the first time that I tried setting this up, I tried using the latest Trixie, and for some reason it was giving me trouble. And as soon as I wiped everything and did a fresh install of Bookworm and tried getting this set up on there, it worked immediately, and so I'm just going to stick to Bookworm, and I would advise you to do the same. I will hit Next. All right, now we need to select our storage device. I will select this SD card here. If you have multiple, make sure that you select the right one. That way you don't wipe something that you don't want to wipe. We'll hit Next. Now our host name, I'm just going to leave it as Raspberry Pi. If yours is, if your field is blank, then you can just type in Raspberry Pi. I think that's the default that the software likes, so that's what I'll leave it as, and I'll just hit Next. Okay. It'll ask for the capital city. I'm in the United States, so Washington, D.C. The time zone, I'm in New York's time zone. And the keyboard layout is US. So I like all that. I'm going to hit Next. Next is the username. I'm going to set the username of mine to Pi, just P-I. You can set yours to whatever you would like. And then we need to set up a password for it. So let me go ahead and type in my password. I will see you in a moment. Okay, after putting the password, I hit Next, and now we are choosing our Wi-Fi. So the SSID, the ID of mine is called Cat Castle because we have 3 cats, and I love them. So need to put in the password for it. I will go ahead and do that both times, and then I'll hit Next. All right, the next step is going to ask if you would like to enable SSH, which is short for shell. It is a method of remotely accessing your device via like a different laptop or a different computer. I do want that on, so I'm going to set that to enabled and select use password authentication, which means you'll just have to put in your password when trying to access your device remotely. I'm going to hit Next. And then this will give us a quick summary. My device is the Raspberry Pi 3. I am installing the legacy 32-bit operating system onto the SD card. and I configured all of this, and I like that very much, so I'm going to hit write. It'll warn you that you're going to erase all of the data on your SD card. Make sure that the SD card that you're using doesn't have any sensitive information on it that you don't want to lose. And as long as it doesn't, you're going to hit I understand, erase, and write. And now it will open it up, it will write that image, and I will see you as soon as it's finished. Hey, would you look at that? We're finally finished. It says that our storage device was ejected automatically. You can now remove it safely. Awesome. We're going to hit finish, and we will pop out that SD card since we are now finished with it. All right, so that was the first step of the software. The second piece of software that I'm going to show you is not absolutely necessary. However, I think that's a lot easier to use the Raspberry Pi Connect instead of having an external monitor set up wherever you're going to be leaving your Pi, because you're already going to have it connected to the internet in order to view the web interface. And so you might as well just use the Connect software in order to remotely see your desktop. So what you need to do is go to the software tab. If you hadn't already, you can scroll down, and Raspberry Pi Connect is right there. Hit it, and then we will sign in. You will need to sign in with your Raspberry Pi ID. If you don't already have one, you can just create one for free. I already have mine, so I will select the sign in option. And once you are signed in, you will see a desktop sort of like this. Now, after you've named your device, it will show up here. I just called mine RPi1. But we can't actually get to it yet because we haven't booted up our Pi and enabled the setting in the Raspberry Pi. So we will go ahead and do that now. Alrighty, I apologize that it'll be janky for just a little bit until we get that Connect software set up. But all I've done is I've taken our micro SD card, put it into the slot. Mine's on the underside. I've set it in there. Let's make sure it's set all the way into that port. All right, now let's power on our Pi. Light comes on, lights are flashing there, so that's good. And then, any second now. There it is. How about that? Okay, like I said before, you will need to have it hooked up to an external monitor for just a little bit until you get that Connect software set up. You don't need to use the Connect software if you don't want to. If you would prefer to just have an external monitor set up wherever you're going to be firing your Kiln and leaving your Pi, that is totally fine. It is up to you. So on the first arrival to the desktop, it's asking us passwords or encryption keys are required to access the Wi-Fi network castle. I will just hit connect because I've already, when we were setting it up in the Raspberry Pi imager, it should have already had the Wi-Fi password. We can see if it is going to connect in this corner up here. It says that it is. It's having some trouble. Let's try to get that worked out. All right, as you can see in that top right corner, if you're having trouble getting the Wi-Fi to connect, it doesn't just automatically connect, then just like any other device, go into your little Wi-Fi selection here, select it, put in your password, and it should connect just fine. Now, what we need to do is we need to click on this little circle button, and it says to turn on Raspberry Pi Connect. We're going to select that, and now it should be on. So you can see it has the option to turn off. That means that it is on. Now that that is turned on, we can set down the camera and connect to the Raspberry Pi via our computer. All right, we are back on the Raspberry Pi Connect website. After you refresh, hopefully your Pi pops up. If you don't have any devices listed here, if it didn't prompt you when you first created your account and signed in, then just hit add device, and you should be able to create your device and connect to it via your account here. Okay, so I'm going to choose to connect via screen sharing. That way we will be able to see the desktop on this remote shell is that SSH that I was telling you about before. The screen sharing is a little more user-friendly though, so I will select that. After a moment, it will load up and you will be able to see your desktop and control your Pi from your computer. Alrighty then, now that we are connected to the Raspberry Pi via the Raspberry Pi Connect, we need to do a few things. First, we're going to come up to this top right corner, select this button, and choose to install the updates. As long as your Pi is connected to the internet, it'll run through and do all the updates, install and download everything that it needs. So go ahead and let it do that. I'll see you in just a second. It might take a while, but eventually it'll finish just like it has here. Let's hit OK, get rid of that. And then let's go up to our Bluetooth and turn that off because we don't need it. All right. You might notice the recording's a little delayed because we're connecting remotely over the internet. It won't affect the performance any. It's just what you're seeing in your screen. It takes a little bit of time to get from your Pi through the internet to your computer, and it compresses it slows it down a little bit. Not a problem though. So we're going to go over to our Raspberry Pi icon here. Go down to Preferences. There's a few things that we're going to edit in the Raspberry Pi configuration here. Give it a second to load up. In the Interfaces menu, you need to enable SPI, and then we will hit OK. It'll say that it needs to reboot. We're going to hit yes, and give it a sec to reboot. You'll lose connection, but worry not. Just give it a little bit to reboot, and then we'll come up to the top left and select Reconnect. Okay, so just give it a moment to reboot. Give it like 1, maybe 2 minutes, and then select that Reconnect button up in the top left, and it should get you back into your Pi. All right, we're going to come up to the web browser here. Left click to open it. Wait a moment for it to load. These Raspberry Pis, especially the older ones, like the 1, the 2, and the 3, they're definitely not known for their speed. So be patient with it. It's going to ask if we want to create a password for the keyring. I'm going to hit cancel because I have no interest in using that. And then we will go to the GitHub page that I showed you before in the last video. So I'm going to type in GitHub, Bruce, Kiln Controller. Hit enter and give it a sec to load. And what do you know, it's right there. First option. We'll click on that, let it load. I'll make it full screen for you. So here we are on the main page for the Kiln Controller project. I'm going to scroll down until I find the installation instructions. So here we are down in the software section. I just scrolled down to find it, and here we have our list of commands that we need to put into the terminal in order to install this project on our Pi. Now, a lot of people are afraid of the terminal. Don't be, okay? It's really not as intimidating as it might seem, and I will help you get through it. The terminal is your friend. All right, so first on our list there is sudo apt-get update. Let's type that in. Then hit enter. Let it do its thing. All right, next on the list is sudo apt-get dist upgrade. Let's type that in. and hit enter. All right, next we need to clone the project from the web page. So we're going to type in git clone followed by the web address. Just like that, hit enter. It'll clone it to Kiln Controller, which will be the title of our folder. Now, if I go up to our little file manager here that I've already opened, you can see it created this folder here called Kiln Controller. All right. Actually, let's take a look at that. I'll show you the different files and stuff inside of it. So if we open up that folder, inside of this folder is our main configuration file, our config.py, as well as a few others that we will need. The most important ones are this kilncontroller.py, which is the main file that we will run, the main executable that we will run when we need to fire our kiln. This test output.py, which lets us test our relays, make sure that they are switching properly, and then this test thermocouple file allows us to test our thermocouple to make sure that it's reading temperatures correctly. So I'm going to X out of that, go back to our terminal, and there we are. Now, next on the list, we need to cd Kiln Controller. CD is short for change directory, or essentially change folder. And go into Kiln Controller, hit enter, and you'll see it updated to say Kiln Controller. So now we are in that directory or that folder. We need to type in Python 3-m venv. What this means is we're going to use Python to create a virtual environment, and we are going to name it virtual environment, venv. Hit enter. It'll think about it for a little bit. I'll see you when it's finished. All right, now that that's finished, next on the list is source vn/bin/activate. Now, I do want to say really quick that in the future, when you go to run the files in your for the Kiln Controller, you do not need to type in this Python 3-m virtual environment every time. You only do that the first time. You do that the first time, it sets up the virtual environment, and then this next command that we're putting in, this source venv bin activate, that activates the virtual environment. We do not need to create the virtual environment again any other time, so we just need to activate it. So we're just going to hit enter, and you can see it started our virtual environment indicated by the venv over here. All right, and now we need to do pip install -r requirements .text. What this is saying, oops, I forgot an I. Let me go back real quick. And right there, boom. If you need to go back and make a change to what you've typed, you just use the arrow keys. All right, so what this is saying is it's going to install stuff from the requirements.txt file. This -r just means that it's reading, that's short for read. And if we go up and I show you that requirements file, give it a second to open, go back into our Kiln Controller, the requirements.txt here, double tap to open that, give it a sec, and here we are. So it will read these application names up here, these different tools, and it will install them automatically from having read them from this file. Okay, it'll also install anything that doesn't have this little pound sign, the little hashtag in front of it. So that is what that command is doing. Let's minimize this, go back to our terminal, and hit enter and let it do that. I'll see you in just a sec. All right, when that is finished, that is all that we really need to do. I will leave this terminal up, go over to the web page here, and you can see here that we already set up and enabled this SPI in the Raspberry Pi menu up here. If you remember, we went to the preferences here. We already done that, so we don't need to mess with those commands. But what I will do is I will run through the configuration file with you because it is rather important. That needs to be set up. That needs to be set up and configured, as well as all of your electrical stuff needs to be hooked up before you can run any of these programs with any amount of success. Okay. First order of business is try not to change anything in here unless you really understand what it means and what you are changing. First thing here that is applicable is the listening port. This is the port that you will have to use when you type into your web browser in order to get to the web interface. It is currently using port 8081, and I don't see any reason to change it, so we will leave it at that, and I would advise you to also. This next section here is where you can put in your electricity information so that it can estimate how much the firing has cost. The next section down here is, so you have a couple options. You can either choose to use hardware SPI or software SPI. You can use whichever one you prefer. The only difference is that the hardware, you have to use specific pins on your Pi. In the software, you can pick whichever pins you want and just specify them in the configuration file below. And you can read through all that if you would like. It's just explaining what you can do. All right, for this next section here, this is the important bit, okay? And I will show you a handy trick that you can use on your Pi to know for sure which pins you are working with. So this command here, this gpio, read all, is installed after installing something called Wired Pi or Wiring Pi. I don't remember the name of it. It's not necessary, so I'm not going to go over installing it here. But if you're interested in it, I'll put the name of the project up on the page, and then you can follow the install instructions there in order to install this. But using this command here, if I hit enter, it will show us all of the pins on our Pi. Let me extend this a little bit. So you can see we have BCM. Okay, this is the confusing bit because when it comes to these pins, they have like 3 different names. There's BCM pins, identifying numbers. There's the name itself, and then there's the physical pin number. And this really confused me when I was first setting it up because I was seeing so many people just saying like pin 5, pin 6, and then some people would say like GPIO pin 21. Some people would say like BCM pin 10, and using all these different names referring to the same pins. So you can find, you can either use this software and use this command in order to view the pin configuration on your Pi, or you can just find a diagram on the internet. But you can use these as helpful tools to help you figure out which of the pins you need to connect your wires to. So getting back to this, these are the pins that I decided to use for the clock. Let me go like that. For the clock, I decided to use BCM pin 11. And that was the confusing bit because there's nothing here indicating what the numbers need to be. These are for the BCM pins. You need to put in the BCM pin number, okay? So I'm using BCM pin 11 for the clock. For the microcomputer in serial out, the MISO, using BCM pin 9. Chip select, CS for short, I'm using pin 8. Microcomputer out serial in, the MOSI, I am using BCM pin 10. And for the output that controls the relay, I'm using BCM pin 16. So these are the pins that I'm using, and the configuration that I have set up. These are the pins on my Pi that my wires are connected to. They're in addition to a few others that are the power pins, which I will show you in a little bit. But as for the configuration file, this is what you need to have set up. This next section here is where you need to define which breakout board you are using. If you're using the 55, then the 1 needs to be next to the 55. If you're using the 56, then the 1 needs to be next to the 56. The 1 and the 0 are essentially just true and false. So this is saying for the 55, it is true. For the 56, it is false. For this next section here, you need to leave these uncommented if you're using the 56 board. How you would do that is, if I can get my little cursor to move, there we go, is you would just remove the £, the hashtag from these, and that will uncomment the line. That way it's not commented out. So the program will read it when it needs to. Let's put those back. If you're using the 56, you also need to specify which thermocouple type you are using. If you're using the K type, then you need to put K at the end here. If you're using any of these other types, then you need to type out thermocouple type dot whichever the type is. B, E, J, K, whichever. Let's move on. The sensor wait time is kind of important. I just left mine at 2. It's not really necessary to change it. It's just how often the thermocouple reads the temperature. Anything. You can change it if you need to. I didn't find any need to, so I just left it. The PID parameters, this is for fine-tuning your thermocouple for your kiln. We can get into that a little bit later. For now, I'm just going to leave it as it is. For this next section here, the simulation section, this is true by default. However, we don't want to run any simulations. We want to do things for real. So I changed the true to a false. Let's keep moving. Scroll back up. I missed this. The temp scale, you can change it from Fahrenheit to Celsius and vice versa. You can change it from hours to seconds to minutes. You can change all of these if you would like to. I'm going to leave mine as Fahrenheit because that's what I'm used to. This next one here, this is the emergency shutoff temp. You need to adjust this depending on whatever the highest temperature, the highest cone is that you're going to be firing your kiln to. I normally only fire mine up to cone 5, sometimes cone 6, so I'm going to leave my max shutoff temp as cone 7. And all the rest in here, I don't think there's any reason to change any of it. You can read through it if you would like and change it if you would like, if changing it fits your needs and your situation. However, in my situation, there is no need to. So the less that you can mess with, the better, in my opinion. So let's close that out. Close this out. And I will show you how to run your test files. So first off, what we need to do is we need to change our folders into that Kiln Controller directory. There we go, we're in. And then, like I said before, you don't need to type in that Python 3 command every time. We've already created the virtual environment. We just need to activate it. I'm going to hit the up arrow to cycle back through my commands that I've typed in previously to this activation one and hit enter. So now the virtual environment is activated. Now what we can do, since we are in the correct folder and we are in the virtual environment, we can type in // test dash output dot py. And when we hit enter, if you have your configuration file set up correctly and all the wires and everything connected on your Raspberry Pi and your breadboard and your thermocouple and everything, and we hit enter, it will turn on and turn off our relays. Let me switch over to the camera view and I will show you what's happening. One sec. There it is. So I can see our relays. They're off and then on when the light is on, and back off and back on. And this is happening each time that the program is switching between heater on and heater off. So that's a pretty handy one. Let's set the camera down, go back to our Pi. If you need to kill a process that is currently running, you hold Control and hit C. C, you can think is short for cancel, and that will interrupt the process. Now for our thermocouple, we can type /test thermocouple .py. Hit enter, and then it will read the temperature from our thermocouple. You can see it's reading 70 degrees right now. If I pick up my thermocouple, oops, I must have hit the wire a little bit. If I hold it in my hand, you can see that it is increasing in temperature. Because thankfully my my temperature right now is above 80 degrees, and so it is going up. And I'm going to hit Control C to get out of that. If you get some of these like error messages while doing your testing, don't worry about it too much. It's just because with the with having things set up on the breadboard, your connections aren't like foolproof. They can very easily just get bumped, and an error can be thrown. Which is why I would recommend soldering all of your connections in the end. But that's for another video. Let me go back over to the camera and I will end this video out. Okay. Back at the camera. Sorry if it's a little jerky, a little bumpy. I'm going to run through some of the pins on our Pi and show you some of the wire connections on the breadboard, as well as the breakout board and our relays. Okay, so for my particular Pi, this is a Raspberry Pi 3B+. These pins up here at the end are our power pins and the white wire. Let me grab some tweezers that I can use as a pointer. This white wire here, that is going to our ground. Again, you're going to want to look up a diagram for your pins. I believe that all Pis are the same. I might be wrong, but I believe that all the GPIO pin configurations for all the Pis are the same. As long as it has a 40 pin header, should be the same. So these pins up here are power pins. This one here in front is a 3.3 volt, which if we follow this red wire, it is going over to our breakout board and connecting to that V in that we can see at the top. That's the voltage in. That's connected in there. We have a red wire. Sorry, let me get the camera focused. We have a red wire, which is actually plugged in just behind this one in front. It's plugged in on the other side. You can kind of see it there. And that is a 5-volt wire. If we follow that, it's going up to this wire nut and then getting upsized and going into one of our relays. It is going into the positive terminal of our relay here. If we go back, we have this green wire here, which is another one of the 5-volt outs. Let's follow that up. That's going to our wire nut, upsizing to a higher, a lower gauge wire, and going into this other relay. Then this white wire here, this is our MASI, I'm not really sure how you say it, the serial in. The 55 chip does not use that, and so even though I have it plugged in, it's not actually connected to anything. You can see it is just laying on the board right there. This brown wire, if we follow it, it is going up into this white wire, going down, going to this resistor here, follow that to this purple, the purple wire, and the purple wire is going to the DO on the breakout board there, the DO. That is our data out. That is how the breakout board communicates with our Pi. Okay. Next, we go down the line here. We've got a red wire. We follow that up, goes into this green wire, goes into the breakout board there, goes into that resistor there, which goes over to that yellow wire. Follow the yellow wire up. It goes over to the clock pin on our breakout. That is the clock pin. Going back to our Pi, let me try to sneak around the side here. We have a purple wire. Let me get this focused. There we go. We have a purple wire going to that connector for that pin. If we follow that up, it goes into breakout board right there, into this resistor down here. From that to this orange wire, followed over to our breakout board here, and is going into that CS pin on the breakout board. That is our chip select. Then down at the bottom here, we have our output pin for the relay. Follow that black wire. It's going into a resistor. And I know it's a little confusing. It might be hard to follow. I'm trying to make it as easy as I can. So from that resistor to that orange wire there, that orange wire is going into that is connected to the base of our transistor. On the right side of our transistor, we have our, there it is. On the right side of our transistor, we have our emitter, that emitter pin, which connects into all of those wires there, which are for the ground. These are our ground wires here. That blue wire that you see is connected to the ground on our breakout board here. And then the left side of that transistor, that pin coming out of the left going into the breakout board, that is our collector. And that is going into the brown and blue cords, the brown and blue wires there, which both go out, get upsized into the wire nuts, and feed into our relays over here. Those go into our negative contacts on both of our relays, and they go into the input side. The input side, that's very important to pay attention. Your relay should say input or output on either side, and you need to pay attention to that because it's important for the voltage. This is using 3 to 32 volts DC. The other side is for 24 to 380 volts AC. Very important. Okay. From our breakout board, this is the last little bit here. From our breakout board, we have the inputs for our thermocouple. The yellow and red wire get hooked underneath the clamps that are in that green housing there. And if we follow that yellow wire, it goes out and around, loop-de-loop, and here we are at the thermocouple. The yellow wire is for the positive, the red wire is for the negative. And those are just clamped underneath those screws on the on this thermocouple mounting block here. All right, Hopefully that was a decent overview of all the wiring. Remember that the wiring, the pins that you need to use, you need to look up a diagram or use that GPIO read all command in your terminal to see what the pin numbers are, and those are the numbers that you need to put into your files, your configuration files. Okay. All right. So this is going to be me signing off. I hope that you enjoyed watching. I hope that I did a decent job at explaining everything. Please leave me some feedback down in the comments. Please be gentle. I don't do this for a living, so sorry if it wasn't very good. But if you found it helpful, you liked it, well then leave a like. And if you are looking forward to, if you'd like to see more, then consider subscribing. All right. Have a good day.